Okay, let's go through this one quickly. 2D. Find the area and circumference of the following circle. Circumference is 2 pi r. Circumference is 2 pi r. Area is pi r squared. So the circumference is 2 pi 4.5 meter. You get 9 pi, or you get 28.274 meter. 3SS 28.3 meter. That's my answer. My area is pi r squared, which is pi 4.5 meter squared. 63.617 meters square. 63.6 meters square. See this part. So the circumference for the next one, this diameter is 16 divided by 2, 8. The radius is 8. The radius is 8. Okay, for this. So circumference is 2 pi 8 cm. 50.265 cm. 50.3 cm. The area is pi r square pi 8 square and 201.06 cm square round off to 3SF 201 cm square. Okay, for this, to find the area of the triangle QRS. So you see this rhombus. Can you see this straight line? Which means all four sides have the same length, 12, 12, 12. So find the area of the triangle QRS. Remember, area of a triangle. This is the base. The height is here. This is the this is the diagonal. You can call it the slanted length or uh slanted length or slanted height. So for this one, it's only a base and height connected by 90 degrees. Area of triangle half times base times height. 96 cm squared. You see this part. So they want to find the parameter of trapezium PQRT. PQRT. They want the parameter of this 12 plus 16 plus 20. 12 plus 16 plus 20 plus 12 plus another 12. So you get the answer. 72 cm. Okay, for this, it's quite fairly straightforward. Okay, this dimension accurate. Accurate means all these are to scale. The length and breadth is the correct length. The length and breadth is correct length. So what is this? What's the name of this special quadrilateral uh parallelogram? Because you have two pair of parallel sides. Parallelogram. Parallelogram is the special name for this shape. So calculate the area of the quadrilateral. Since this is the area of an accurate diagram, right? How can you find the area of this? Remember, you can cut it into half. You use a ruler to measure this length, and you use a ruler to measure this length. This is your base, this is your height. So the area will be half times base times height times 2, because there's 2 of this. This one will be the same base, this will be the same height. So that's why you have times 2. From there, you get your answer in cm. I think you use a ruler to cm squared. Okay, for this, you can measure this on the paper itself, then you'll be accurate. 2D. 2D is on a different page. Just look over. The length of the square base is 20. The square base means that all sides are the same. That's 20. Including this length is also 20. The vertical height is 35. The slanted height, the vertical height is this one. From here, this one is 35. The slanted height is this one. This is the slanted height. Can you see this one will form up to be a right angle triangle, which will come out to be this one. This is half of the 20 is 10. Because this right here is only half of the 20 is 10. The vertical is 35. The L is here. So again, how to find this? ABC, Pythagoras theorem. A square plus B square is C square. So 35 square plus 10 square is the length square. I bring the square over square root. The first calculator. 36.4. 36.4 cm. This is the slanted length. Find the total surface of the pyramid. What do they mean? They want you to open up the pyramid, which becomes like this. Which becomes like this. So the slanted length, this one is 3.6, 36.4. All these are 36.4. This one is 20. This one is also 20. You see this part. So the total surface area is half times base times height times 4. Because there's 4 of this triangle plus 20 times 20, which is come from the area of the square. You see this part. If you press this into the calculator, press all this into the calculator, you get 1856 cm squared. That's your answer. That's your total surface area. Oh, okay for this part. Okay for this. The diameter hemisphere, question 5. The screen of the sphere covers 80% of the surface area. Calculate the curved surface area. So the curved surface, the area of the screen, right? 80% of the curved surface area. So the formula is the curved surface area is 4 pi r squared. So which will be 4. The radius is 23 divided by 2 because the 23 is the diameter. Radius is only half of it squared. 1669. 161.9025. Then there is 80%. So 80 over 100 of 1661.9025. 1329.522. 3SF 1330 cm. Okay for this part. Okay for this. The next one. Convert 4.2 cm into meters. Divide by 100. 0.425 meter. That's all. Calculate the total surface of this container. So you see how to find the total surface of this. We talk about surface area first. What is the area of this? This is a circle, pi r squared. Pi times 42.5. Oh, they want meter squared, so let's change to meter. Pi times 42, 0.425 meter squared. So bottom there's also 1. Bottom is also pi r squared, pi 0.425 meter squared. How to find the, the area of this part, the side this part. So the area of this will be 2 pi r times h. 2 pi 42, 0.42, 2 pi 0.425 times 1.1. This will be the curved surface area. So if you add all this together, 2 pi 0.425 times 1.1 plus pi 0.425 square plus pi 0.425 square. Total you get this 4.07228 meters squared. 4.07 meters squared. Okay, for this will be the answer for this part. The next one, 7. Our part cross is a trapezium. Calculate the volume of the soil. The volume of the soil is the area of the trapezium, which is this part, times the length. That gives you the volume. It is the area times length. That will give you the volume. So the area of the trapezium is half times the sum of the parallel sides. Area of the trapezium is half times the sum of the parallel sides times the perpendicular height, which is h, which is 16. This is the area of the trapezium. Then to find the volume, you times the length, which is 50. Then together they give you the volume. Okay, okay for this. Then to convert this into cm cube, you times 60, which is 100,000. This part 3. How many soil such benefits there is given that there is 0.1 liter cube of soil? How many such power force can be filled? So um, times yes, only one. If there's only you need 152 0, yeah. So this is 100,000 divided by 15200. 6.5789. You can only fill 6 spots. That's all you can fill. Okay, for this only 6 spots. Okay. 8. A Sunday cone can be modeled by a hemisphere of a cone. Find the volume of the Sunday cone. So the volume of this is 1/3 times base area times height. which is 1/3 times pi. The radius is 2.2 cm. The height is 12 something cm cubed. Then the volume of this is 4/3 times pi 2.2 cubed. So if you plan calculator, you get the answer. So in total, right, you place this together, you should get 105.423 cm cubed. 105 cm cubed. This. Okay, for this part. Then the individual cones are sold in box of 6. Each cone comes without packaging, 6 grams per city, and the total mass is the mass of the cone. So the mass, right, will be this. So I convert this to be grams per 0.6 gram per meter cube without the standard cone. So this will be 105.423 times 0.6 gram plus a box of 6 plus the box of 6, which base of 6 is 63, 63.2538 grams. Then plus the box and the packaging 12 gram, 75.2538 gram. Now off to nearest gram, 75 gram approximate. Okay, for this question is a bit tough. Okay, read through again and see how is it. Next one. Find the arc length and sector area of this. The arc length is this. This is the arc length here, which is S is R theta 119 times 1.3 meter. Yeah. Yeah. So this is not the one. This is the one for the sector units. So arc length S is equal over 360 times 2 pi r, which is 119 over 360 times 2 pi 1.3 meter. 2 pi 2.7000 meter. 2.7 meter. Find the sector area. The area for this will be equal to 360 times pi r squared. 119 over 360 times pi 1.3 squared. 1.75 1.75 times 4 3SF 176 meters squared. Okay, for this part, I miss out this one. should be 2.70 meter, 3SF. Okay, for this. The next one, find the arc length. The arc length of this is meter over 360 times 2 pi r 325 over 360 times 2 pi 20. 113.446 113 cm. The area will be theta over 360 times pi r squared. 325 over 360 times pi 20 squared. You just sub in the formula, you can get out the answer. This part is nothing difficult for this. You just put in the formula, you do 3SF 1130 cm squared. Okay for this part. Yeah. The next one. So question D. So the sector with the radius 12 cm and 13 angles between the top layer of the cake. Find the surface area of the top of the cake. Find the color of the top side of the cake. Which means they want this area. They want this area. So the surface area on the top side of the cake, which will be theta over 360 times pi r squared 36 times 60 times pi 12 squared. 45.238 cm squared. 45.2 cm squared. You see that. Then we create a plastic sheet we get around the side of the cake. Find the perimeter. Calculate the perimeter of sector to find the shortest length. Calculate the perimeter of the sector to find the shortest length. Opposite in the correct to the nearest cm. We want the perimeter of this sector. So what's the perimeter of this? It should be 12 plus 12. I want you to find out this arc length. The arc length is 36 over 60 times 3 times r. 12 cm. 10 times 4 times 7 times 1298 cm. Then to find the parameter, we should need to add the sides plus 12 plus 12. And then it is 12 plus 12. So be 31.539. You are off to the nearest cm. 32 cm. This is your running index to find the surface length of the cluster index. Okay, for this, it gives us a try, see how is it. Try the exercise 2 A, B, C, D, and A. This will help you on revision for the coming WET. If any question, you can ask in class and stuff. Okay, for this, see you. Bye.